chapter 4 in your Desjardins book, and approximately 1213 from chapter 50 in your Hess book. So last week we talked about pressure gradients, and pressure gradients are movements of gas from area of high concentration to areas of low pressure gradients or low pressure concentrations. When we're talking about diffusion, we're talking at a smaller level. So we're talking about the movement of gas molecules from an area of high concentration to an area of low concentration. So what we're talking about specifically are the molecules of oxygen and carbon dioxide. So if you look here at this picture, we've continued to talk about where the oxygen comes from, and that's the ambient environment. And it's those pressure gradients from our respiratory muscles, our diaphragm and our intercostal muscles, that pull that air down into our lungs and expand our alveoli. And in that area, and in that case, oxygen is pulled in from the environment, and then it comes through the tracheobronchial tree, and then down in the alveoli is where it meets the blood capillary and it diffuses across the alveolar capillary membrane. Carbon dioxide diffuses from the blood into the alveoli, in which we move it out. So here's a good depiction of the alveolar capillary membrane. So you can see the top is a micro picture here of the alveoli itself, and it's showing that oxygen is coming into the alveoli. That's its greatest concentration. And then it's going to move through all of the layers, so the alveolar epithelium, the loose space, the basement membrane, the interstitial space, and then go through the capillary membrane itself, and it's going to connect right here on to the red blood cells, specifically onto the hemoglobin, and it's going to move to the tissues, and that's where it's going to exchange gas. Carbon dioxide, once again, starts in the tissues, hitches a ride through the red blood cell, diffuses from its high to low concentration gradient. Then when it gets into the alveoli, it travels up through the tracheobronchial tree and exhaled. So when we talk about internal respiration, we're talking about the exchange between the tissue cells and the red blood cells. Okay, so oxygen travels from the alveoli on the red blood cells and moves into the tissue to supply them the oxygen they need to finish out all the processes they need. So we need that aerobic environment for the tissues to be able to perform what they need to perform. And then carbon dioxide, as a byproduct of cellular respiration, it gets created in the tissue cells, and it travels then onto the hemoglobin and back to the alveoli. So internal respiration is the exchange of gases between the tissue cells and the red blood cells. And when we talk about tissue cells, we mean all of the cells in our body. So we mean the systemic cells, all of the organ systems in our body. Where external respiration takes place at the alveolar capillary membrane between the red blood cell and the alveolus.